Okay, here we go with Form 72F, June 16 ACT. The second passage here deals with an amusement park ride, a cart being dropped and then striking the spring and then coming back upwards. So let's take a look at the first question you missed here. Number 11, at time equals 7 seconds, the bottom of the cart is approximately how far above or below point P? Okay, so let's go back here and take a look at our diagram as well as the figure 2. So they're asking about the 7th second, and we want to know how far above. Okay, so look, here's your 7 seconds. We're going to come all the way up to this top graph, and I can see that cart would be at the 40 meter mark. Okay, but this particular question is asking how far above or below point P. So look at your diagram. P is essentially your y-intercept on this graph here. So you're starting out at 50 meter height. At 7 seconds you're 40 meters. Therefore you are 10 meters below that starting point. Okay, so that being said, it looks like C is going to be your best answer there on 11. So again, when you're looking at that, you might initially say, well, you're at 40 meters, which is true, but this question is asking how far above or below a particular position, which is your starting point. So you're 10 meters below point P. You still are 40 above, but that's not what that question is asking. It's asking how far below the P you are. Alright, then we go to 12. The gravitational potential energy of the cart is greatest at approximately what time during the 20-second period? Okay, so gravitational potential energy is all about position. Alright, so how far, where are we the greatest height? Okay. So 0, 4, 11, or 14. Okay. So at 0, I'm 50 meters. 4, I'm about 5 meters. 11 and 14. 11 is about 10 meters and 14 is about, 37 meters. So of all those, your potential energy is going to be the greatest where you are the highest, in the highest position, because this is due to position. If you remember, gravitational potential energy, I believe, is let's see, is it mgh? Mass times gravitational acceleration times height. So if the first two variables are constant, then it's really all about your height. So at the in the very beginning, at 0 seconds, you're 50 meters high. That's going to be your greatest gravitational potential energy. All right, then we move to question 30. We're looking at this passage here. Now this is the type of passage where you actually are probably going to want to read it first. Most of the other questions you do not, but for any of these passages where you have conflicting arguments or different scientists' perspectives, you want to go ahead and read it first. Okay, let's take a look at the question. Fossils of the photosynthetic organisms mentioned by scientist 2 would most likely have been found from 710 million years ago to 700 million years ago in areas at which of the following latitudes? So if we go to scientist 2, okay, we have glacial ice covering all of the surface except the low latitudes. And if you had already read Scientist 1, the low latitudes are defined as 30 north to 30 south. Okay, so that's the only area that's receiving sunlight. So it's the only area that conceivably would have anything photosynthetic. And we're looking at photosynthetic organisms being fossilized. So the only position that is between 30 north and 30 south, this is too far north, this is too far north, and this is too far south. So H is going to have to be the best answer there. Okay, and then we go to 33. Suppose it were discovered that most of the Earth's surface between 30 and 60 latitude was ice-free 705 million years ago. This discovery would contradict one or more statements by which of the scientists, if either. So if you go back to your two scientists, they both were claiming that glacial ice covered the Earth's surface except low latitudes. Okay, even here, ice covered all of Earth's surface except the low latitudes. So they're both agreeing on 30 to north to 30 south being the only ice-free area. So if we come back and say that we have this discovery that we're going from 30 north all the way to 60 north, that's 30 degrees above here that would be ice-free. So that's going to actually contradict what both of those guys are saying. So your best answer is going to be C on that. Okay, and then we go to this passage. This passage deals with the ideal gas law. So let's take a look at your first question here. It looks like 37. In experiment 1, was the average kinetic energy of gas Y molecules more likely greater at P equals 2 or P equals 4? Okay, so let's take a look. Experiment 1, figure 1. If I look here, all the trends are basically the same, so let's just look right here. At a pressure of 2, I got a temperature about 225, and then a pressure of 4, I've got a temperature about 450. Now that's not mentioning anything specific about kinetic energy, but you got to remember, temperature and kinetic energy, for all practical purposes, are the same thing. When your temperature is greater, that literally means your molecules are moving with more kinetic energy. So therefore, at that greater pressure of 4, you will have a greater kinetic energy. So let's take a look at your choices here. At let's see, at pressure, no, so right away we can say, look, we're not going to have more kinetic energy at a lower pressure, so that rules out these two. So now it's between C and D, which is where you have greater pressure. Okay, because at a higher pressure the gas molecules, and again, it doesn't have anything to do with the volume, it has to do with temperature and kinetic energy being directly related, so D is your best option there. And then going to 39, 1 mole of gas Y has a mass of 20 grams in experiment 2. What was the mass of the gas Y sample when the pressure was 25 millipascals? Okay, so let's go to experiment 2. Okay, so if we have a pressure of 25 millipascals, so here's 20, here's 30, so I'm going to come right between here and go until I intersect gas Y, and if I come down, that's 5 moles. Okay, and what does this problem say? It says 1 mole is 20 grams. So if I have 5 moles, that's going to give me 100 grams total as that sample mass. Okay, so again, you don't want to just read it for what it says. Okay, yes, at 25, at a pressure of 25, that would be 5 moles. And so you might be thinking, okay, well, it's got to be 5 grams. Well, this question's asking, it's not asking for the moles, it's asking for the mass of the sample. So if I have 5 moles, then based on this, 1 mole equals 20 grams, then 5 moles has to equal 100 grams.